Alright, in this video I'm going to cover the 2011 free response questions number 1 through 3, looking at my solutions and grading them using the rubric. So in question 1A, trying to see if it follows a normal model. Basically in the rubric I'm seeing if the minimum is how far below, how many standard deviations below the mean it is. So looking at the rubric, it's essentially correct if you state the answer of no and provide an explanation based on the relationship between the mean, standard deviation, and minimum. Partially correct if you say no, but you have a weak explanation. So you'll notice here I calculated a z-score, got negative 0.1333, calculated a probability of 0.091, and it said no, the minimum is only 1.333 standard deviations below the mean. We would expect if it was approximately normal, that minimum would be about 3 standard deviations below the mean. So I answered no, and I have a reasonable explanation. This would earn essentially correct. Part B. In Part B, we're asked to calculate and interpret a z-score for this player. So I did stat minus mean over standard deviation to get 2.4 for standard deviation. So that means the player can lift 2.4 standard deviations more than the mean weight for all players at this position using previous strength data. Looking at the rubric, it's essentially correct if I calculate a z-score and provide a correct interpretation, including direction. So I need to say it's 2.4 standard deviations above the mean, not just away from the mean. That would only earn partially correct. So this is going to be an essentially correct as well. In Part C, we're trying to figure out which player the team should select based on their running time and their amount that they lifted. So what I did is I calculated z-scores for their running time and the amount of weight that they lifted. Keep in mind, for running, the faster you go, the better, so you want to be below the mean. So for player A, a negative z-score of 1.2 is better than negative 0.2. For the weight lifted, you want to be above the mean, so you can see player B is a little bit better. Okay, as far as grading goes, I'm going to be taking a look at, it's essentially correct if you select player A, you have numerical adjustments so you can compare the times and the amount of weight lifted, and you justify why you selected the player based on both variables. So I said player A, so that's component 1. I have my numerical adjustments, that's component 2, because they are faster and can lift almost the same weight as player B, so I'm talking about both. I also talk about the absolute value here of the sum of those. That would be 3.6. This would be 2.8. So this would be essentially correct. So looking at the scoring rubric, all 3 parts are essentially correct. This I would have earned a 4 on question number 1. Okay, take a look at question number 2. This is the probability question where you're given this contingency table, and given that a randomly selected voter is a male, so it's a conditional probability. What's the probability he registered for party Y? So given he was a male, there's 200 males total, that's my denominator, out of which 48 registered for party Y, so 48 out of 200. You can leave it as a fraction or you can change it to a decimal. In Part B, I want to know, are the events being male and registering for party Y independent or not? So using the independence formula, this is not on your green formula sheet, so this is something you need to know for your exam. I already have this information in Part A, so I might as well use it again in Part B. That was 0.24. The probability that they're registered for party Y is 168 out of 500, which is 0.336. So, are they independent? No, the events of being a male and registered for party Y are not independent because their probabilities are not equal. That's all I need to say. I don't need to go any further. So actually, let me look back at the scoring rubric before I go any further for Part 2. Or question 2. Okay, so Part A of the 200 registered voters. Okay, there's your probability for Part A scoring. Part A, it's essentially correct if you have the correct conditional probability and shows the work. I have the correct conditional probability and I showed some work here. So that's correct. Part B is essentially correct if you have correct computations of the 2 values, both sides of the equation, an explicit statement on whether they are equal or unequal, and an appropriate conclusion about the independence. If you have 2 of those 3, it's a P. So you'll notice here, I have the correct computation for both. I explicitly said they are not equal, these probabilities, and I talk about are they independent or not right here. So this would also earn an E. Okay, getting into part C, I thought this was a hint that part B was not independent because now they're saying, what if it is independent of gender? So I thought that was a little bit of a hint to tell me that in part B, they were not independent. That's what I should have gotten for part B. So here's what the graph looks like. They need to be exactly the same. Basically, gender doesn't have any impact on what party you're in or you're registered for. So to calculate those, I took 88 out of 500 to get the percent for party Y, 244 out of 500 for X, and 168 out of 500 for Y, for W, X, and Y. Okay, so 17.6% plus another about 49%. So I was at 17%, added about 49% to get to here, and then the rest were party Y. So let's take a look at grading this question. Essentially correct if it shows the same conditional distribution for both males and females. Got it. Includes correct proportions for each party and correct labels. Okay, so I have the same conditional distribution. I showed my proportions here, and I have the correct labels. This is going to earn essentially correct. I have all of them essentially correct. I'm going to earn a 4 on this question. All right, so let me get rid of some of this on there. Okay, looking at question number 3 next. Okay, so this is your experimental design question and sampling, specifically sampling.
And this is going to be talking about stratified sampling versus cluster sampling. What are the benefits of one versus the other?
And why. All right, so let's do this. Okay. So part A, you're being asked to describe a process for randomly selecting these 8 different apartments. So looking at the scoring guidelines here, a couple of things we need to hit to earn credit here. It's essentially correct if you address these 2 components. That the 2 floors are randomly selected with all apartments on each floor forming the sample. Talking about cluster sampling, you break the population into clusters, you randomly select some of those, and then you sample everything in those clusters. Okay? So, give me 1 second to move away from the sun and get rid of this glare. Okay, that's better. Okay, so that's your first component. Second component, you need to describe a valid random sampling procedure that a knowledgeable statistics user could use to get the same floors. Okay, yeah, one of those 2 things, it's partially correct. So if we just take a look for a moment at what they did. Step 1, generate a random number between 1 and 9 using a calculator. Select all 4 apartments on that floor. Step 2, generate another one. If it's the same, repeat, blah, blah, blah. Okay, pretty straightforward here for part A. So I said I'm going to randomly select 2 floors after labeling them from 1 to 9. Using a random number generator, use the first 2 numbers, ignoring repeats. That is key. If you're not talking about ignoring repeats, that's a problem. Then sample all 4 apartments on those 2 floors. So I have that I'm selecting all the apartments on those floors, and I'm talking about following this procedure twice, using the 2 first randomly selected numbers. So this is going to be essentially correct. If you're leaving out something like ignoring repeats, you're going to earn partially correct because you could select the same one twice. Part B, they want to know why a stratified random sample would be better, given a statistical advantage here on why that would be better. Okay, so basically, in my mind, that's a hint that A is probably not good for some reason. So for part B, earning credit here, there's 2 components. The amount of carpet wear could be different for apartments with and without children. And the benefit of doing the stratified random sample is we guarantee that we're going to get some apartments with children. Okay, so I said here, by using a stratified random sample, you're guaranteed to have some apartments with and without children. So there's that one component. And this is a statistical advantage if we believe the amount of wear on the carpets could be affected by having children in the apartment. There's the second component. So two things. Stratified random sampling guarantees that you're going to get some apartments with children and without, and we're specifically measuring the amount of carpet wear and how it could be different for those two different types of apartments. So that's E. Because there's only two parts here, essentially E is going to earn you 2 points, P's are going to earn you 1 point, and you can see that on the rubric accordingly. So this would equate to a 4. Okay, that's it for this video. In the next video, I'll go through questions 4 through 6.